All right, good morning. Happy Thursday. Let's just go through one thing at a time here. First of all, you have an exam tomorrow at 8 o'clock. Just a reminder, I'm not giving retakes, I'm not taking late scratch paper, I'm not doing any of that. So remember that I did that last semester and you should know how I roll at this point. So just make sure you're doing everything you need to do. Your devices should all be working properly. Nobody's notified me of their devices not working properly. So we should be good to go. So exam tomorrow, 3132 at 8 o'clock. All right. So the first thing I want to do is I want to take any questions you might have for the exam. So does anybody have any questions on 3.1 or 3.2? All right. Well, also due tomorrow night is an assignment. And yesterday I was telling all my classes, make sure that you're writing things on a calendar, you're keeping track of when assignments are due, because I'm not taking any late work. And so this assignment 3.3 is due tomorrow. And no one's asked me any questions about it. So anybody want to ask me any questions about 3.3? So 3.3 was the product property, the quotient property, and the power property. We also went into expanding and condensing in the change of base. So 5 objectives. Anybody want to ask me about lesson 3.3, or anyone want to ask me any questions about 3.3? Anybody want me to work a problem? All right, so no one has any questions about the exam tomorrow, which is 3.132.
Miss Birch.
Yeah.
I was just having a little bit trouble with for lesson 3.3, 37.
Okay.
Like I've been just confused. I've been stuck on that.
Yeah. Okay. Well, 37. I'm not going to give anything that hard.
Okay.
So I can absolutely do it. But do you have any questions on problems like 1 through 20? Do you have any questions on those? I'm not going to give anything as hard as 37.
Would you have a question like 13?
Yeah. Now remember, that's not on this test, right? So 3 is going to be. Okay. Yeah. So yeah. You said 13, right?
Yeah.
Okay. Okay, you guys, I'm doing problem number 13 on page 475, and this is lesson 3.3. All right, so 13 is a natural log. Now remember, Bernie, that this is log base e. So you have to remember that that thing is log base e. All right, so we have natural log of e squared over 5. So the directions say use the properties to expand. Expand means make bigger. So remember that we can take division and change it to the subtraction of 2 logs. So this would be the natural log, this would be the natural log of e squared minus the natural log of 5. Now, since this means log base e, do you notice that this would be log base e of e?
Yeah.
So log base e of e squared would be 2. And there is nothing more to do. So we did expand it, and that is the answer.
Okay. I think for me, it's just understanding like the e. Do you know what I mean? But I'm good now with that.
Well, there's a bunch of, in this lesson, there's a bunch of hidden things.
Yeah.
And one of the hidden things is this natural log means this. So what you really have here is you have log base e of e squared, which is that property I gave you.
Mm-hmm.
So I gave you a property that says that the base of the log equals the base of the exponent. They cancel.
Mm-hmm.
Right?
Right.
So that's what you have to remember there, is you have to remember that what natural log means. And natural log means log base e. I could do it. I could do another one. I could
Is
do
it
another
okay
one.
if I talk about 3.2?
Yeah, hold on just a second though.
Okay.
Let's do number 5. So number 5 has some hidden information also. So let's do number 5. So number 5 is, it just has a log, but you have to remember that that means log base 10, right? So, and then it has 1,000x. Well, they're asking us to expand this. This is a product, so that means we're going to change it to the sum of two logs. So this would be log base 10 of 1,000 plus log base 10 of x. Well, if this is a 10, can't we get 1,000 to look like a 10? And wouldn't that be 10 cubed? So now wouldn't you have log base 10 of 10, which is 3? So you have to know the rules. If you don't know the rules or understand the rules, you won't be able to do these problems. You must understand the properties in order to do these problems. You okay, Bernie? Anybody else? You guys okay? Anybody else want me to work a problem in 3-3? Bernie, did you see what I did in this problem, huh?
Yeah.
Okay.
Like number 5 kind of gave me a resemblance towards a problem in 3.2. I forgot which one it was called, but we were doing something like that. Yeah. But I was gonna ask you a question about 3.2, if that's okay.
Yeah. Hold on. I'm gonna address it. I just want to make sure nobody has anything else in this section first. Anybody have anything else in 3.3? The assignment is due on Friday night.
Can you do another similar problem like number 5?
Sure. How about number 7? So number 7 says log base 7 of 7 divided by x. So they want us to expand. So the first thing you want to notice is quotient means division, right? So division to expand means we need to subtract 2 logs. And you're going to put the 7 here and you're going to put the x there. Well, what's log base 7 of 7 to the, there's a 1 power there, right?
Yeah.
So class, what is this? Log base 7 of 7 to the 1 is what? Class?
1.
1 minus log base 7 of x. So just remember, when you have a product, you're going to change it to adding 2 logs. If you have a quotient, which is division, you're going to change it to the subtraction of 2 logs. That's the properties. Did you follow that?
Yeah.
Okay. All right. Anybody want me to do another problem in 3.3? Okay. Go ahead, Bernie. What were you going to ask me?
I was just having a little bit of trouble for 3.2 with 5.5. I mean, 55.
3.2, number 55?
Yeah, that's it. Yeah.
Okay. They're actually trying to trick you on this problem. And there might be a problem on the test like this, so it's good you're asking me. All right, this is not A. So A is always multiplied to the quadratic, multiplied to the cubic, multiplied to the logarithm. A is always multiplied. Well, that's not multiplied. So if I were you, I would rewrite this to log base 2 of x plus 1, so you know that that's K. So that's also not H because it's not in parentheses, right? So to be H, it would have to be in parentheses. It's not in parentheses, that's K. So what you're going to do first is you're going to graph the parent. So you need 2 points, and we know the asymptote for the logarithm is vertical. So we're going to pick a 1. Log base 2 of 1 is 0 by the property. You're going to pick a 2. Log base 2 of 2 to the 1 is 1. So we're going to graph the parent. So they're also going to ask for the asymptotes. So this asymptote is x equals 0. We're going to go right 1, 0, and we're going to go right 2, up 1, and we know that this logarithm looks like that, right? And they're going to ask, I think in this problem, they ask for the domain and range. Yes, they do. So the domain is to the right of 0 forever, and the range is forever up and down. So remember what I said yesterday, this is a 5-point problem. So this is heavily weighted, so you must know what you're doing. All right, so now we know that this is up 1. So you just take your parent points, leave the x alone, and move it up 1, up 1. Now, who moves a vertical asymptote? A, B, H, or K? Right, H is moving it. So we don't have an H. H is 0. So it's not being moved. So we have the same asymptote. Remember, the exponential functions have a horizontal asymptote, right? The logarithms have a vertical asymptote. Okay, here we go. So we go right 1, up 1, and we go right 2, up 2, and you draw the graph along the asymptote. So that's h of x, and the black one is f of x. I'm sorry, okay, the black one is f of x, right? And the red one is h of x. And now we do the domain of h. He's the same. He's 0 to the right forever, and the range is forever up and down. So the 5 points are 1, 2, 3, 4, and the graph. And make sure you practice the online problems so you know how to enter them in the computer. All right, did that help, Bernie? Did you get it?
Yeah, I was, because the main thing was they were trying to trick me, and that's why I was like, so am I going left 1? Or, do you know what I mean? But now I understand because you explained it.
Right.
Yeah.
So let me just say this. If you have this, that is absolutely a vertical stretch by 3 because it's being multiplied to the logarithm.
Mm-hmm.
When they're adding something like that, that is not A. That is K. So, and the other thing is you're only going to see H if it's in parentheses. So that would be left 1. So I don't care what this looks like. This is up 1. So this one, can you guys see this? This is left 1. This is up 1.
Yeah.
Okay. So remember, in parentheses is your horizontal movements. Outside the parentheses is the vertical stretch or compression, the vertical up or down, the vertical reflection. Okay, can I erase this? Okay, anybody else have anything for the exam? So hopefully you've been studying. You know, you've had a lot of time to study. I've given you a lot of time to do stuff. Make sure you know how to enter things on the computer.
Ms. Birch, I have one more question.
Yeah.
For 3.1, are we going to see a problem like 49 or 50, like either one of those problems?
3.1, 49 or 50. I can't, let me look. I mean, number 49 is a vertical compression by 1/3, and number 50 is a vertical stretch by 3. You're asking me about number, did you say 49 or 50?
Yeah, like, are we going to be seeing a problem like that?
I would make sure you know how to do 49.
Would you
So
mind
make
doing that
sure,
problem?
I'm not going to do it.
Okay.
You should be able to do it. It's a vertical compression by 1/3. Since I'm telling you it's on the exam, make sure you know how to do it. Okay, so make sure you know how to do 49. The f of x is the parent, and g of x is a vertical compression by 1/3. That means you multiply the y by 1/3. Do you want me to show you g of x, what it is? I'm not going to do the problem. I'm telling you it's on the test, so I'm not going to do it. So g of x is 1/3 times 3 to the x. So 3 to the x. All right, the parent is 3 to the x. So the parent is 3 to the x. You have to find the parent points, and there's a horizontal asymptote at y equals 0. After you find the parent points, well, we can do it real quick. Put a 0 in, you get a 1. Put a 1 in, you get a 3. What are you going to do? This is a vertical compression by 1/3. So what do? You multiply the y by what? Class?
1/3.
1/3.
So when you multiply by 1/3, you get 1/3. When you multiply 3 by 1/3, those cancel. Right?
Right.
All right. You can do the rest, right? Yes?
Yeah.
This is 3.1, number 49. Yeah, it's a 3-point problem. Make sure you know how to do it. Okay, anything else about the exam? All right, today I'm going to teach lesson 3-4. There's 4 objectives. All right, so we're actually going to be solving equations with exponential and logarithmic. Well, they're exponential and logarithmic equations. And so this is lesson 3-4. And the objectives are on page 478. And we're going to be doing, look at all the problems on page 488. So these are all solving problems. So these are exponential and logarithmic equations. Okay, once again, I may not be teaching like the book, but just know that I'm teaching the most efficient way, I'm teaching the easiest way, and my notes are way more organized than the book. All right? All right, so the first thing we're going to do is we're going to use like bases. To solve, what's solve mean? Evaluate means find a number. What's solve mean?
Find the variable.
Yeah, find the variable. Now, I've actually never seen the name of this property, so I made up my own name. I'm calling it the same base, and this is what it says. It says if b to the m equals b to the m, in other words, if you can get the base, if you can equate the bases, then you can get rid of b and just say m equals n. Now, I know that's a weird property, but it's a very useful property. when you have easy problems. So let me show you how this works. And by the way, in this lesson, the problems are going to go from easy to hard. All right, here we go. So let's say you have 2 to the 3x minus 8, and it's equal to 16. Now, the reason why this is an exponential equation is not because there's an exponent, it's because the variable is in the exponent, and we got to get him down from there. So the question is, how do we get him down? Well, this would be one way to get him down. If we can get the bases to be the same, we can get rid of b completely and bring him down. So here's the question. You cannot make a 2 look like a 16 without messing up the problem. Can you make 16 look like a 2?
No.
You can't?
Oh, wait, yeah, you can.
2 to the 4th isn't 16? But do you notice what I did? I got the base to be the same, so guess what? I get rid of 2 and write 3x minus 8 equals 4. And I don't know about you, but that's pretty cool. So once again, if you can get the bases of the exponents to be the same, you can get rid of the bases and equate the powers. Isn't that neat? So now we just solve for x. So we add 8, divide by 3, x equals 4. So this is a solution. This is where the graph is crossing the x-axis. So if I were you, I would put it in a solution set. Okay, now you probably see what's going to happen. It's going to be like, okay, that's cool if we can do that, but what if we can't get the bases to be the same? Then what do we do? So let's do another one like that. Do you guys have any questions so far?
So, Ms. Birch, specifically with this, for the first step, if we can, right? It's just common sense, because obviously, like, 2 does go into 16 4 times, right? So it's just basically using your.
Okay, I'm gonna change what you said a little bit.
Mm-hmm.
You're right, 2 does go into 16, but we're not doing that. Remember what this means. This means 2 times 2 times 2 times 2. So you're right. 16, 2 does go into 16 8 times. But what we're doing here, 2 to the 4th means 2 times 2 times 2 times 2. So that's how we're getting 16.
Okay.
We're not doing this.
Mm-hmm.
And what you're asking, Bernie, is what a lot of people are confused about. So I'm glad that you're asking. That's really good. So remember what 2 to the 4th means. It does not mean 2 times 4. It doesn't mean anything but this. This is what it means. It means multiply the base 4 times. That's what it means. It means multiply the base 4 times. Does that help?
Yeah, thank you.
Okay. All right, so let's try another problem, guys. 27, that's a special number, to the x plus 3 equals 9 to the x minus 1. Now, this is an exponential equation because the variable is in a power. We have to get him down from there. So pay attention to what I'm saying here. You cannot make a 9 look like a 27. And you cannot make a 27 look like a 9. But what can we do? Anybody know what we can do?
Can you make them into 3?
Yes. So we're going to write 27 as 3 times 3 times 3 to the x plus 3. And we're going to write 9 as 3 squared to the x minus 1. Now, do y'all agree that 3 times 3 times 3 is 27 and 3 times 3 is 9? Okay, now watch what I'm going to do. We cannot use the rule right now. We have to distribute this. So this is going to be 3 to the 3x plus 9 is equal 3 to the 2x minus 2. So you see how I distributed the monomial to the binomial? The monomial to the binomial. Remember, power to power, you multiply. That means you have to distribute, right? So now look at what we have. We have the rule. And so we can say that 3x plus 9 is equal to 2x minus 2, and we get rid of the bases. So now we just solve for x. So subtract 2x would be x. Subtract 9 would be negative 11. So our answer is negative 11. All right, go ahead. Any questions about this one? So this was a little bit harder, right? This one was easy. We just say one side, 2 to the 4th. Over here, we had to mess with both sides. Questions?
Miss Birch, can you explain how we got 11 again? Negative 11.
Yeah. When you subtract 9, it goes away. When you subtract 9, a negative and a negative is a negative, and you add.
Okay. Okay.
Right? And when you subtract 2x, it goes away. And when you subtract 2x, you get 1x. So I'm using algebra to solve. You okay, Bernie? Hello? Okay, now, like I said, what happens if you can't get the bases to be the same? What if you get this? They ask you to solve. Well, we can't make a 4 look like a 15. We can't write bases of 2. We can't make a 15 look like a 4. We're just stuck. So do you guys remember? Well, let me just show you. You can either, we want to take a natural log to both sides. Watch this. Let me do a different color. I can do anything I want to this, right? As long as I do both sides. So I'm going to do this. And you're probably wondering, what the heck is she doing? So watch this. So this would be the natural log of 4 to the x equals the natural log of 15. Well, can I use the power property? Remember the power property? It's like, okay, you come down. So he's going to come down. And guess what I'm going to do? I'm going to solve for x by dividing both sides by the natural log of 4. And now, remember the other day when I gave you the change of base? Remember that? Well, it works with natural logs too. So here's what we can do. We can what? Oh, we don't have to use the change of base. Look at this guy's on the calculator. So can't we just put this in the calculator? Natural log of 15 divided by natural log of 4. So this is going to be an approximation. So can you guys tell me what it is?
1.95344.
Yeah, so about 1.95. And you should do everything by hand unless you get stuck. And you are stuck here. So everything has to be done by hand, so you get exact answers, but you are stuck. Okay, now let me just review this. We cannot get the bases to be the same. So if you can't, you're going to take a natural log to both sides because it's on the calculator. So, or you can take a log base 10 to both sides. It doesn't matter. So I want to show you the natural log works too. So you take a natural log to both sides. You use the power property to get the variable down. And then you just solve for x by dividing. And now you just put that in the calculator. Now let me show you how it works with the log. So yesterday, I said you could take a log base 10 to both sides for change of base. So you would have 4 to the x equals log base 10 of 15. So you're going to use the power property. You're going to divide both sides by log base 10 of 4. And you could do it just to show yourself that you're going to get the same answer. You're going to get the same answer as we got over here. So it doesn't matter what you do. You can take a natural log to both sides, or you can take a log base 10 to both sides. Because either way, you can put a natural log in the calculator, or you can put a log base 10 in the calculator. Right? So did you guys do it? Turned out to be 1.95, right? Yes. And I want to show you something else. Look over here real quick. Isn't this about 2? Isn't 4 squared 16? See how close they are? So this answer makes sense. Because it's almost 2 and 4 squared is 16. It's real close to 15. You don't need to know that. Just throwing in some stuff here. All right, any questions about what to do when you can't get the bases to be the same? Let's do another problem. Now remember, we are only solving exponential equations right now. We haven't done the logarithms yet. These are just exponential equations. What about this one? All right, now first of all, you gotta simplify this. So you have to have something equal to something, not all this fluff. So what I would do is I would add 3 to both sides. And when you add 3, you get 240. This is not part of the exponent, right? So can I divide both sides by 40? So if I divide by 40, I get a 6. And if I divide by 40, I get this nice problem. Do you want me to show that, or do you understand what I did? I divided both sides by 40. Okay, now you decide what do you want to do to both sides. And since that's an E, I'm going to take a natural log to both sides because you can't get the bases to be the same. And so I'm going to get them down a different way this time. I'm not going to use the power property. Watch what I'm going to do. Isn't this log base E of E? So if this is log base e of e, can I just write 0.6x by the property? And now what we're going to do to solve for x is we're going to divide both sides by 0.6, and we're going to use a calculator. So once again, we're going to get an approximation. So go ahead and put it on your calculator. What is natural log of 6 divided by 0.6?
2.986.
2.99. About. Okay, now remember what I told you. The problems are getting harder, so I'm going to do 2 more. All right, we're still not looking at logarithmic equations. We're still looking at exponential equations. And this guy is exponential because of the variables. We can't get the bases to be the same. So you have to decide, I'm going to take a natural log to both sides to get him down from there. So we get natural log of 5 to the x minus 2 equals the natural log of 4 to the 2x plus 3. And now I'm going to use the power property. So make sure you put this in parentheses. If you do not put it in parentheses, it will be wrong. So that binomial as a power has to come down in parentheses. That binomial in a power has to come down in parentheses. And guess what we're going to do? We're going to distribute. So this is going to be x natural log of 5 minus 2 natural log of 5. Distribute 2x times the natural log of 4 plus 3 times the natural log of 4. So I just distributed. And you guys notice that I have an x here and an x there? Well, you want to put the x's together. So I'm going to put the x's on the left. So you're going to add 2 natural log of 5 to both sides. And you're going to subtract 2x natural log of 4 to both sides. Hold on a second. Hold on 1 second. Yeah, that's right. So this disappears and this disappears, but you can't combine those. That's a natural log of 5 and a natural log of 4. So I have to rewrite it. X natural log of 5 minus 2x natural log of 4, because those are not like terms. And it's equal to non-like terms over here. And it's like, how is all this going to work? Well, I'm going to show you right now. You're going to do a GCF and take that x out. So when you take out the x, you get this minus 2 natural log of 4. And now to solve for x, you're going to divide both sides by natural log of 5 minus 2 natural log of 4. And you're going to have to put all that in the calculator. So you're going to want to put this in parentheses, and then you're going to divide by that in parentheses. So let's see if you can get the right answer. and then I'll explain what I did again. So you're going to say 3 times parenthesis, 3 times natural log of 4, parenthesis, plus 2 times natural log of parenthesis, 5, and parenthesis, and then divide by the bottom. So let me know what you get when you get it. Let me negative. Anybody get it?
I don't know if it's right, but I got 1.831.
It's actually negative 6.34. You have to be real careful with the parentheses. So it's 3 times natural log of 4 in parentheses plus 2 natural log of 5 in parentheses, and those are all in parentheses. And then you divide by parenthesis. That 5 goes in parentheses, that 4 goes in parentheses, and then another parenthesis. Was anybody able to get it?
I got it.
Okay. Okay, so I just want to make sure I did it right. All right, so let me explain this problem, okay? Okay, first of all, you cannot get the bases to be the same. So when you take a natural log to both sides, you're going to use the power property and get them down. The reason why this problem is so hard is because you have to distribute a binomial. So when you distribute, you get this statement, and what you're going to do is put all the x's on one side and put the ones without x's on the right. So if you notice, see all the x's on the left and all the non-x's on the right? So if you get all the x's on the left or wherever, you can take out an x, like a GCF. So if you take out an x, you can get rid of this other garbage. And then this obviously has to go in the calculator because it's too complicated to do by hand. All right, any other questions? You guys think you could do it? You just have to practice on the calculator.
I had a question. When you distributed it, why didn't the natural log of 5 and natural log of 4 get affected? Like when you did negative 2 times the natural log of 5.
Okay, hold on. When you distribute, these go out in front. So this is x natural log of 5 minus 2 natural log of 5. When you distribute this, you get 2x natural log of 4 plus 3 times natural log of 4. So when you distribute, these numbers go out in front of a logarithm. They don't go into the logarithm.
Oh, okay, because I was questioning, like, why wouldn't it be like negative 10?
Yeah, no. You okay, I'm glad you asked this Whatever in the logarithm can't be touched. So it's like he's in jail. You can't touch him. You can't talk to him. You can't touch him. You can't do anything. So these guys, so for example, if you have like the natural log of 5, you could mess with this too. You could divide by 2, but you can't mess with him at all. You can't touch him. If he's inside a logarithm, you cannot touch him. So these numbers are just being multiplied to the front of the log. They're not touching the guy inside. So when you distribute, this becomes x times the natural log of 5. And this one becomes -2 times the natural log of 5. You cannot touch that 5. Do you understand what I'm saying, everybody?
Yeah.
And I'm really glad you brought that up because I wanted to explain it, but I forgot. Yeah, because I'm never going to touch the logarithm, and I assume my students won't, but they do. So I'm glad you brought it up. Okay, take a look at this guy. I don't know about you, but doesn't he look like this? Doesn't he look like a quadratic? So if they want us to solve, we could factor this using factoring method 5. What multiplies to give 3 and adds to give -4? -3 and -1, right? Yes? So what would our answers be? What makes the 0?
3.
What makes that 0?
1.
Yeah. So it's like, okay, wouldn't it be nice if we could do this? Well, I'm going to try to do it. Pay attention, please. When you multiply the e's, don't you add the exponents? So wouldn't this be e to the 2x? 1x plus 1x is 2x? Right? And then what multiplies to add 3 to give multiplies to give 3 and adds to give 4 would be -3 and -1. Now I'm going to check to make sure I did this right. Watch. FOIL. When you multiply monomials with the same base, you add the exponents. When you do the outer, this would be -1 e to the x. When you do the inner, it'd be -3 to the x. I'm sorry, -3 e to the x plus 3. So this number looks good. This number looks good. Does this equal -4? Is -1 and -3 negative e? Those are like terms, aren't they? Isn't that -4 e to the x? So that's how you're going to do these. You're going to change it to a quadratic and do the quadratic, and then try to tackle this weird problem. Now, we're not done yet, because what makes this 0? It's not 3. So look what you have to do. You have to take e to the x minus 3 and set it equal to 0 and solve for x. So this would be e to the x when you add 3 to both sides. You're going to take a natural log to both sides. So you get e to the x, natural log of 3. You're going to use the power property, the variable down. And you're going to divide by, hold on a second. Isn't log base e of e 1? So isn't this just x? And so couldn't you just put that in the calculator? Did you follow all that? So we did the factoring, but now we have to find out what makes this 0. So don't you have to set it equal to 0? It's not like this where we could say, what makes that 0 too? We're not doing easy things like that anymore. So when you set it equal to 0, you solve for x. Well, you isolate the variable, get him down from there by taking a natural log to both sides, use the power property to get the x down. And I was going to divide both sides by that, but isn't log base e of e to the 1 just 1? So isn't that x times 1? So what's natural log of 3 on the calculator? We're not done yet either. We have to solve this one.
It was 1.098.
So about 1.1. And now we have to do this one. So we're going to do the same thing. Add 1 to both sides. Take the natural log to both sides to get him down from there. Well, we know log base e of e to the x is just going to be x, right? Oh, look, we could have done that here, you guys. Look, hold on. I can show you a better way. Look, isn't log base e of e to the x just x? So we can skip some steps. Right? Log base e of e to the x is x. So x is about equal to, I think everyone said 1.1. And then over here, same thing. Log base e of e to the x is x. And what's the natural log of 1? 0. So you have two solutions. You have 1.1 and 0. So this graph is crossing the x-axis. I don't know what it looks like. It's crossing the x-axis at 1.1, 0, and 0, 0. So on this one, you wanted to factor. So see how the factoring keeps coming back? Okay, now, I'm not going to teach anymore today, but I've only done a third of the lesson. So what I've done today is I've taught you how to solve exponential equations with the same base, and I taught you how to solve exponential equations when you don't have the bases the same. All right, next time we will solve logarithmic equations. These are just exponential equations. Now, we use logarithms to solve them, but these are exponential equations. Every problem I gave you was an exponential equation. And obviously, you're not going to worry about any of this right now. You're just going to study for the exam. All right? So you're not going to start this tonight. No. But after the exam tomorrow, you should be starting on this while it's fresh in your mind. So this was just solving exponential equations. Anybody want to ask me a question about anything? Obviously, these two were more challenging. All right, here's what I want you to do. You're going to go into your Math Wizard teams, and you're going to work the online problems for the exam. So it's up to you. You can work problems out of 3.1 or 3.2 or both. I gave you some hints yesterday about what problems to study. So make sure you know how to do those problems, because you know they're going to absolutely be on there. All right. So, and I will be taking attendance in the Math Wizard teams. Anybody want to ask me about anything right now?
Doing the online problems for the exam.
Exactly. All right. And we are not going to, and I hope you guys do well on the exam tomorrow. If you have any questions, I'm here. So just call me into your room. I'll be checking in. All right. Okay. Good luck on the exam 3132. And I'll see you in your Math Wizard team.